Hi students, this video covers the previous year questions from the first chapter, applications of matrices and determinants. Given A is equal to matrix 2 minus 1 3 minus 5 3 1 minus 3 2 3. This is a 3-mark question under the compulsory problem. So this is a given matrix. We are asked to find the value of determinant of edge of edge A. So determinant of edge A, we know that determinant of edge A is equal to determinant of A whole power n minus 1 the whole squared. In this given matrix, here the order of the given matrix is equal to 3, and therefore edge of edge A is equal to determinant of A whole power 3 minus 1 the whole squared, which is equal to determinant of A squared the whole squared, which is equal to determinant of A power 4. So it is enough we find the determinant of A and then find and raise to the power of 4. So determinant of A here, in this video we see a short trick to find this determinant of A. So what is this trick here? To find the determinant of A2 minus 1 3, we write the elements of the matrices inside the determinant, and then we repeat the first two columns of the determinant. We repeat the first two columns of the determinant: 2 minus 5 minus 3 minus 1 3 and 2. Now next step, what I am going to do is I am going to take these diagonal elements and multiply. Take the diagonal elements, multiply these elements, and what is that we are getting? This is equal to product 2 into 3 into 3. 2 into 3 is 6, 6 into 3 is 18, plus next line minus 1 into 1, minus 1 into minus 3 gives me plus 3. Next 3 into minus 5 minus 15 into 2 gives minus 30. This is the first bracket. Next step, we are going to take the elements along the diagonal. So here multiply the product of these elements, and so we get this is equal to, I subtract minus of the elements. Here minus 3 into 3 minus 9, minus 9 into 3 minus 27, plus the next element 2 into 1 is 2, 2 into 2 is 4. The next element 3 into minus 5 minus 15, minus 15 into minus 1 gives us plus 15. Now this is equal to 18 plus 3 21 minus 30 gives me minus 9, minus of here 15 plus 4 19, minus 27 is minus 8, minus of minus 8 gives us plus 8. Now the value of the determinant is equal to minus 1. Value of determinant of A is minus 1, and therefore now our aim is to find edge of edge A. Therefore edge of edge A is equal to determinant of edge A is equal to, we know it is determinant of A whole power 4, so which is equal to minus 1 whole power 4, which is equal to 1. Next question. Prove that, it is an important 3-mark question. Prove that the matrix cos theta minus sin theta cos theta is orthogonal. This is an example 1.11, important 3-mark question. Prove that the given matrix is orthogonal. So let us take the matrix A is equal to the matrix cos theta minus sin theta cos theta. Now it is enough if we prove that we know the condition for orthogonal. It is enough to prove that if A transpose is equal to A transpose into A is equal to I, then we know that it is equal to I and show that the given matrix is orthogonal. So A is the given matrix. We find what is A transpose. A transpose, the first row becomes the first column, or the first column becomes the first row. So I write it as cos theta sin theta. First column becomes the first row. Then the second column becomes the second row, that is minus sin theta cos theta. We have written A transpose. Now take the product of A and A transpose. A transpose will be is equal to cos theta minus sin theta, cos theta into the product of the transpose, that is cos theta, sin theta, minus sin theta, and minus sin theta plus sin square theta. So the first element is cos square theta plus sin square theta. First row, first column over. Next we multiply first row, second column elements. Cos theta, sin theta, product is cos theta into sin theta, minus sin theta into cos theta is minus sin theta cos theta. Next we multiply the second row and the first column elements. So the second row sin theta cos theta plus cos theta of minus sin theta gives us again cos theta sin theta minus cos theta sin theta. Next the second row, second column elements, cos the sin theta into sin theta, sin square theta, cos theta into cos theta, cos square theta. So that is sin square theta plus cos square theta. Now the value for this is equal to, so here sin theta cos theta becomes 0, and therefore we get this is equal to 1 0 0 1, which is a unit matrix of order 2. So we have proved that A transpose product is equal to the unit matrix, which implies that A is orthogonal. Next question, solve the system of linear equations by matrix inversion method. Two linear equations are given. So this is again a 3-mark question here. This question is from exercise 1.3, first question. Two linear equations are given. Let us write the equations. 2x plus 5y is equal to minus 2, and the next equation is x plus 2y is equal to minus 3. Now we write the matrix form of the given two equations. The first matrix will be the coefficient of the x and y, the elements containing the coefficients of x and y of the first linear equation, and the second linear equation coefficients is 1 and 2. Coefficient of x is 1, coefficient of y is 2, into the unknown variables, that is x and y, is equal to the constant matrix, which is minus 2 and minus 3. Now the matrices of the form Ax is equal to B. Now our aim is to find, in order to find this x matrix, I multiply both the sides by A inverse, pre-multiply by A inverse on both the sides. We get x matrix is equal to A inverse into B, and therefore here to find A inverse we have to find the value of determinant of A. So determinant of A will be is equal to determinant of 2 5 1 2, which is equal to 4 minus 5 is equal to minus 1, not equal to 0. We find edge of A. So edge of A will be is equal to find edge of A. Edge of A is 2 minus 5 minus 1 2. Now find A inverse. This A determinant of A is not equal to 0. Therefore we say A inverse exists, and therefore A inverse will be is equal to 1 by determinant of A into adjoint of A. Now this is equal to 1 by minus 1 into 2 minus 5 minus 1 2. Multiply by minus sign inside the bracket, we get minus 2 5 1 minus 2. This is A inverse. Now we are going to find what is X matrix. So now therefore X becomes is equal to the product of A inverse and the B matrix, that is X is equal to A inverse matrix is known to us, that is equal to minus 2 5 1 minus 2 into the B matrix, that is minus 2 minus 3. Now this is equal to, take the product, multiply the first row and the column here. So we get minus 2 into minus 2 is 4, 5 into minus 3 is minus 15. The second row and the column matrix is minus 2 plus 6, which gives us this is equal to 4 minus 15 is equal to minus 11 and 4. Now the value of x and y, this x matrix is nothing but is equal to xy matrix. Therefore we get x is equal to minus 11 and y is equal to 4. Next question, if f of alpha is equal to given matrix, show that f of alpha whole inverse is equal to f of minus alpha. It is a 2023 3-mark question. This problem we have seen already. We have to first take the RHS here. We will write what is given. Given f of alpha is the given matrix. So cos alpha 0, sin alpha, next 0 1 0, minus sin alpha 0 cos alpha. We find the RHS first. RHS is f of minus alpha, which is equal to, we know that cos of minus alpha is equal to cos alpha and sin of minus alpha will be is equal to sin alpha. So we apply here f of minus alpha, cos of minus alpha will be cos alpha 0, sin of minus alpha will be minus sin alpha. This is 0, 1, 0. Minus sin of minus alpha becomes plus sin alpha 0. Cos of minus alpha is cos alpha. We have found the RHS, have it as equation number 1. Next we find what is the LHS. LHS we are asked to find what is f of alpha whole inverse. To find f of alpha whole inverse, first we find what is the determinant value. Therefore, determinant of f of alpha will be is equal to determinant of cos alpha 0 sin alpha 0 1 0 minus sin alpha 0 cos alpha. Expanding the determinant, we get this is equal to cos alpha into the minor of this. So cos alpha into 1 into cos alpha is cos alpha minus 0. So cos alpha gives us cos square alpha. The next element is 0. Next plus sin alpha into, we get 0 minus of minus sin alpha. So it gives us sin alpha gives us sin square alpha. Cos square alpha plus sin square alpha is equal to 1. So this is not equal to 0. Therefore we say f of alpha whole inverse exists. Now we find what is f of alpha whole inverse. To find f of alpha whole inverse, we want to find the adjoint of f of alpha. We have seen the shortcut method to find the adjoint in the previous video. So I use the shortcut method here. What is the shortcut method? We move on from the middle element of the middle column, move downwards from the middle element. So 1, 0. Next again move upwards, 0, 1. So proceed in the third column, we get 0 cos alpha sin alpha 0. Next we proceed on to the first column. Similarly move from the middle element. So we get 0 minus sin alpha cos alpha 0. Next again move to the middle column, 1, 0, 0, 1. Now the value is 1 into cos alpha minus 0 gives us cos alpha. Next 0, next element is 0, 0 minus sin alpha gives us minus sin alpha. Next 0, next element is 0, cos alpha into cos alpha is cos square alpha minus sin square alpha gives us the value as 1. The next element is 0 minus 0 is 0. Next is 0 minus of minus sin alpha gives us plus sin alpha, and the next element is 0. The next element is cos alpha into 1 is cos alpha in minus 0. So the value is equal to cos alpha. This is the value for adjoint of f of alpha. Therefore we know that determinant of f of alpha is equal to 1, and therefore f of alpha whole inverse will be same as adj of f of alpha. So that is 1 by 1 into cos alpha 0 minus sin alpha 0, 1, 0 sin alpha 0 cos alpha. Let us have it as equation number 2. We'll refer what is equation number 1. Equation number 1, this element is minus sin alpha, this is sin alpha. So equation number 2, the same we get. Therefore from 1 and 2, conclusion is a must for the problems. So marks are allotted for the conclusion. So we write f of alpha whole inverse is equal to f of minus alpha. If A is equal to the matrix, verify A into Hj is equal to Hj into A is equal to determinant of A into I. Let us write first what is given. Matrix A is equal to 8 minus 4 minus 5 3. To find Hj of A, Hj is equal to, interchange the diagonal elements, change the sign of the non-diagonal elements, so it becomes A, 3, 4, 5 and 8. We have found what is Hj. Now find the product of A into Hj, which is equal to 8 minus 4 minus 5 3 into at GA is 3 4 5 8. Taking the product first row first column elements, we get this is equal to 8 into 3 24 minus 4 into 5 minus 20. Now first row second column elements we take, so first row second column 8 into 4 32 minus 32, 4 into 8 32. Next we go on to move on to the second row first column element, so that is minus 15 plus 15. Second row second column elements will be minus 20 plus 24. Now the value of A into GA is 4004, which is equal to 4 into the unit matrix 1001. Let us have it as equation number 1. Now we move on to the next part, that is GA into A. So GA into the product A is equal to 3 4 5 8. GA into the A matrix, that is 8 minus 4 minus 5 and 3. Now make the row by column operation. We get 8 into 3 24, 4 into minus 5 minus 20. First row first column over. Next first row second column we get minus 12 plus 12, second minus 40. Next second row second column minus 20 minus 24. Second row second column elements is 5 into minus 4 is minus 20 and 8 into 3 is 24. So now GA into A is equal to, we get 4004. Again this is equal to 4 into the unit matrix 1001. Let us have it as equation number 2. We find now what is determinant of A. So the determinant of A will be is equal to determinant of A. This is the A matrix, 8 minus 4 minus 5 3, which is equal to 24 minus of minus 5 into minus 4 is 20, which is equal to 4. Now determinant of A into the I matrix will be is equal to 4 into 1001, which is equal to 4004. Now this is equation number 3. Now we see from 1, 2 and 3 we get that, we say that A into GA is equal to GA into A is equal to determinant of A into I. Hence prove. Moving on to the next problem, GA, prove that if GA is equal to the given matrix, we are asked to find the A inverse. You know the formula for A inverse? A inverse we know is equal to plus or minus 1 by root of determinant of GA into GA. So using this we are going to find what is A inverse. Now let us write what is given. Given here A is equal to GA is equal to, given GA is equal to the matrix 0 minus 2 0 6 2 minus 6 minus 3 0 6. Now we find what is determinant of GA. Determinant of GA will be is equal to determinant of 0 minus 2 0 6 2 minus 6 minus 3 0 6. Expand into the minor of it. 6 into 6 gives us 36. 6 into 6 is 36 minus 18 plus 0, which is equal to 2 into 36 minus 18 gives us 18. So that is equal to 36. Now determinant of A is known to us. Therefore, we find what is A inverse. A inverse is equal to plus or minus 1 by root of 36 into the GA matrix already given in the question. 0 minus 2 0 6 2 minus 6 and minus 3 0 6, which gives us this is equal to plus or minus 1 by 6 into the matrix 0 minus 2 0 6 2 minus 6 and minus 3 0 6. A inverse. The next question, March 2021 3-mark question. Find the rank of the given matrix. This is an exercise 1.2 first question. We do the sum by minor method, but here since it is not mentioned in the question, we do by the rank method. For that, let us take let A is equal to the given matrix 0 1 2 1 0 2 4 3, third row 8 1 0 2. Now in order to bring it to the echelon form, we have the first element, the condition for the echelon form is the first element of the given matrix must be a non-zero entry. Next, the second row first column, must be is equal to, we have to bring it to 0. 3a 31 element and a 32 element, we have to bring it to 0. That will be the echelon form of the matrix. So a 2 1 element must be brought to 0 and a31 and a32 must be brought to 0, then it is in the echelon form. So in order to transform that, I transform the given matrix by taking the interchanging the R1 and R3. So the R3 elements become the first row. So elements of the first row 8 1 0 2. Second row remains as it is. The first row comes to the last row, that is 0 1 2 1. Now the transformation made here is R1 and R3 are interchanged. The next transformation, already A21 element, A31 element is 0. Our aim is to make this element A32 element to 0. So the transformation what we can do here is R3 I am going to transform to 2 times of R3 minus of R2. So the first two rows remains as it is 0 2 4 3. The last row transformation 0 2 into 0 minus 0 is 0. 2 minus 2 becomes 0. Here 2 into 2, 4 minus 4 becomes 0. 1 into 2 is 2. 2 minus 3 becomes minus 1. Now, the given matrix is in a row echelon form. Number of non-zero rows of the given matrix will be is equal to 1, 2 and 3. Therefore, here we write number of non-zero rows is equal to 3. The matrix is in echelon form. Number of non-zero rows is equal to 3. Therefore, we say the rank of A is equal to 3. The matrix is in echelon form. Next question. Again solve by matrix inversion method. Two linear equations are given. We are going to solve by the matrix inversion method. So the given equations are 5x plus 2y is equal to 3. This is given. And 3x plus 2y is equal to 5. So we write the given equations in matrix form. The elements coefficient matrix from the first equation becomes 5 and 2. The next coefficients from the second equation are 3 and 2. The unknown variables are x and y, which is equal to the constants 3 and 5. The matrix is of the form Ax is equal to B. Our aim is to find this X matrix, and therefore X will be is equal to A inverse into B. To find A inverse, we first find what is determinant of A. So this is A matrix here. Therefore determinant of A will be determinant of 5 2 3 2, which is equal to 10 minus 6, which is equal to 4, not equal to 0. We say A inverse exists. Next we find adjoint of A, where adjoint of A is equal to 2 minus 2 minus 3 and 5. Now we find what is A inverse, which is equal to 1 by determinant of A into adjoint 2 minus 2 minus 3 and 5. Determinant of A value we know is equal to 4. Now we find what is X here. X we know is equal to A inverse into B, that is 1 by 4 into 2 minus 2 minus 3 5 into the B matrix, that is 3 and 5. Multiplying both the matrices, we know to multiply two matrices by the row column method. So now this is equal to 1 by 4 into first row and the column. 2 into 3 is 6, minus 2 into 5 is minus 10. Second row and the column, minus 3 into 3 is minus 9 plus 25, which gives us this is equal to 1 by 4 into minus 4 and 16. Now divide these two elements by 4. The elements are minus 4 by 4 gives us minus 1, 16 by 4 gives us 4. This is the X matrix. X matrix is nothing but the consists of elements X and Y, and therefore we say that here X is equal to minus 1 and Y is equal to 4. The next question, solve by Cramer's rule the system of equations. Three equations are given in x1, x2, x3. So solve by the Cramer's rule. Let us write the given equations first. This is a 5-mark question. So x1 minus x2 is equal to 3. First equation, 2x1 plus 3x2 plus 4x3 is equal to 17. Second equation, x2 plus 2x3 is equal to 7 is the third equation. First we find what is delta. Delta is nothing but the coefficients of x1, x2, x3 in all the three equations. We take coefficient of x1 is 1, then x2 is minus 1, there is no x3 in the first equation, we take 0. The second equation, coefficient of x1 is 2, coefficient of x2 is 3, coefficient of x3 is 4. Next, the third equation, coefficient of x1, there is no x1, we take 0 here, coefficient of x2 is 1 and coefficient of x3 is 2. Expand the determinant along the first row, so we get 1 into 6 minus 4. Next element, minus of minus 1 gives us plus 1 into 2 into 2 is 2 into 2 is 4 minus 0. Next element is 0. So now this is equal to 1 into 2 plus 1 into 4, which gives us is equal to 6, which is not equal to 0. Next, now delta is equal to 0. Now next we find what is delta 1. How to find this delta 1? Delta 1 is nothing but we replace the elements of the first column by the constants in the three equations. So we get delta 1 here. Now delta 1 will be is equal to replacing by constants the coefficients of x. So given as 3, 17 and 7. Now we expand along the first row. So 3 into 6 minus 4 plus 1 into, we get 17 into 2, 34 minus 28 plus 0. Now this is equal to 3 into 2 plus 34 minus 28. 6, which is equal to 6 plus 6 is equal to 12. Next we find delta 2. To find delta 2 will be is equal to, the first row will remain as it is. The second column elements are replaced now. The second column elements are replaced with the constants, what we did in the delta 1. So the constants are 3, 17 and 7. So first row, the coefficients of x1 in the three equations will remain the same. Coefficients of x1 in the three equations remains the same. Coefficient of x2 we write it as 3, 17 and 7. And now the third column remains as it is. Now this is the value for delta 2. Now delta 2 is equal to 1 into 34 minus 28 minus 3 into 4 minus 0 plus 0, which gives us this is equal to 6 minus 12 is equal to minus 6. Now similarly we do for delta 3. So now delta 3 will be is equal to replace the last column by the constants. First row will be 1, 2 will be, the second column will be minus 1, 3, 1. Minus 1, 3, 1. Last column will be 3, 17 and 7. Now this is equal to, let us expand along the first column here. So we get 1 into 7 into 3 is 21 minus 17. Expanding along the column, so minus 2 into, we get minus 7 minus 3 plus 0. Now this is equal to 4 minus 2 into minus 10, which is equal to 4 plus 20 is equal to 24. Now we have found the values of delta, delta 1. We have found what is delta, that is equal to 6. Delta 1 is 12. Now delta 2 minus 6. Delta 3 is 24. Now we apply the Cramer's rule. What is this Cramer's rule? Cramer's rule only when delta, where here x1 will be is equal to delta 1 by delta, y1 will be is equal to delta 2 by delta, and here no y1, x1, x2, the variables are x1, x2 and x3, which is equal to delta 3 by delta. Delta 1 We have got the answer as 12. Delta is 6, so value is equal to 2. Delta 2, as we saw, is equal to minus 6 divided by 6, which is equal to minus 1. Delta 3 is equal to 24 divided by 6, which is equal to 4. Therefore, answer is x1 is equal to 2, x2 is equal to minus 1, and x3 is equal to 4. Another important question solved by using Cramer's rule is a 5-mark question. 3 linear equations are given and the equations are of the form 1 by x, 1 by y, 1 by z. 3 equations are given. Equations are in the form of 1 by x, 1 by y and 1 by z. So we'll write first what is given in the question. The 3 linear equations are 3 by x minus 4 by y minus 2 by z. Minus 1 is equal to 0, so I take it as is equal to 1. The second equation is 1 by x plus 2 by y plus 1 by z is equal to 2. And the third equation is 2 by x minus 5 by y minus 4 by z is equal to minus 1, taking to this one to the right side. Now this equation, let me simplify the given equations by taking a is equal to 1 by x, b is equal to 1 by y and c is equal to 1 by z. The equations are rewritten as 3a. The first equation can be written as 3a minus 4b minus 2c is equal to 1. The second equation can be rewritten as a plus 2b plus c is equal to 2. And the third equation can be rewritten as 2a minus 5b minus 1. We rewrite the given 3 equations. Now we find what is delta from this. Delta is a coefficient of x, y, z in the first equation. So 3 minus 4 minus 2. From the second equation 1, 2 and 1. Third equation 2 minus 5 minus 4. Now this is equal to 3 into minus 8 plus 5. Next, minus of minus 4 gives us plus 4 into minus 4 minus 4. 1 into minus 4 gives us minus 4 minus 2. Minus 2 into minus 5 minus 4. Now this is equal to 3 into minus 3 plus 4 into minus 6 minus 2 into minus 9, which is equal to minus 9 minus 24 plus 18, which is equal to minus 15. We have found delta. Next we are going to find what is delta 1. Delta 1, here this delta 1 we have to replace the base of the a elements by the constant terms. It gives us delta 1. Now delta 1 is equal to, the constants are 1, 2 and minus 1. So it is replaced here, 1, 2, minus 1. Second column remains as it is. Third column also remains as it is. We expand the determinant, which is equal to 1 into 8 plus 5. Next element plus 4 into minus 8 plus 1 minus 2 into minus 10 plus 2. Minus 4, and so here we get minus 4, here we get minus 8. So minus 8 plus 5 gives us minus 3. The next element is plus 4 into minus 7 minus 2 into minus 8, which is equal to minus 3 minus 28 plus 16, which gives us is equal to minus 15. This is delta 1. Now we find what is delta 2. Delta 2, the coefficients of the b is being replaced by the constants. Now delta 2 will be is equal to, the first row remains as it is as 3, 1 and 2. Minus 1, third column remains the same, minus 4. Now this is equal to 3 into minus 8 plus 1 minus 1 into minus 4 minus 2 minus 2 into minus 1 minus 4. Now this is equal to 3 into minus 7 minus 1 into minus 6 minus 2 into minus 5, which gives us this is equal to minus 21 plus 6 plus 10, which is equal to minus 5. Next we find what is delta 3. Delta 3, the third column is replaced by the constants. The second column elements are minus 4, 2, minus 5. Minus 4, 2, minus 5. And the last column we replace it by the constants, that is 1, 2, minus 1, which gives us this is equal to expanding along the first row 3 into minus 2 plus 10 plus 4 into minus 1 minus 4 plus 1 into we get minus 5 minus 4, which gives us 3 into 8 plus 4 into minus 5 plus 1 into minus 9, which is equal to 24 minus 20 minus 9, which is equal to minus 5. Now we have found the values for delta, delta 1, delta 2 and delta 3. Delta 1 minus 15, delta is minus 15, delta 1 is minus 15, next delta 2 minus 5, delta 3 is also minus 5. Let us write now delta, we got as delta is equal to minus 15, delta 1 is also minus 15, delta 2 is minus 5 and delta 3 is also minus 5. Grammar's rule, where the Grammar's rule is A is equal to delta 1 by delta, which is equal to minus 15 by minus 15. B is equal to delta 2 by delta, which is equal to delta 2 is minus 5 by minus 15, which is equal to 1 by 3. And C is equal to delta 3 by delta, which is equal to minus 5 by minus 15, which is equal to 1 by 3. Here the A is equal to 1 we get. Now A is equal to 1, B is equal to 1 by 3, C is equal to 1 by 3. The equations are in the form of x and y. We know that A is equal to 1 by x, B is equal to 1 by y and C is equal to 1 by z. Therefore here A is equal to 1 by, A is equal to 1 x, B is equal to, we got the answer as 1 by 3 is equal to 1 by y, and C value is 1 by 3, which is equal to 1 by z, which implies that x is equal to 1 and here y is equal to 3 and z is equal to 3.